This is a good question. So, if you have seen my other video on distance time travel graphs, and this can be like a test question for yourself to check if you are able to do it. Okay, so the question is presented as a story, and then you need to provide solution with numbers, right? The solution would be part of expressing in terms of numbers. And then I also want you to take some time to draw the graph. What would the graph look like? So let's do this together. So if you have whiteboards, I don't know how your teachers practice with you. If you do have whiteboards and markers, go for it. Otherwise, have your maths book ready to go. If you have a graph book, then it's even better. So get ready with your stuff. All right, while I'm reading this as part of the story. On Saturday morning, Lily left her house at 9 a.m. to visit her friend who lived 6 kilometers away. She walked at a steady pace and reached her friend's house by 9:30 a.m. After chatting for 30 minutes, Lily realized she had forgotten her phone at home. So she walked back home at the same speed, arriving at 10:30 a.m. After picking up her phone, she rested for 15 minutes, then decided to grab her cycle and back to her friend's house at twice her walking speed, arriving at 11 a.m. All right, so I think I have read at a very slower pace so that everybody who are listening can actually process the information. But before I show the solution, you can have some think time. Okay, so the questions that can follow up here would be like the time that she took, okay, her basically her journey segment analysis. So her walking time from to friend's house, the stationary chatting time, how long was it, and then walking back time, then resting at home, and then cycling back. And once you do all this on your graph, we can talk about your speed, because speed, as we have discussed in the previous video, speed is not there technically. You are graphing time on x-axis, distance on y-axis, but when you do the change in y over change in x, which is our distance over time, will indirectly guide us to our speed, right? So I'll give you some think time on this. Get your graphs ready to go. So I'm assuming you can pause the video and practice it out, but it should look something like this. So she's starting at 9 a.m. and then she's reaching to her friend's house at 9:30. Then she spends some time, that's a stationary bit, right? No change in speed. And then she's heading back to her home. So they'd have to all the way come down to what it would look like here. Then there is again she spent some time, 15 minutes at home. And then she used her bike to head back, and this time at twice the speed. So let's talk about the information here that is being represented. So I hope your graph looks something like this. So if you want to understand her journey segment, walking to her friend's house from 9 to 9:30, she did 6 kilometers in 30 minutes. So that ended up being 6 over. Remember, I told you in the previous video as well, if our responses are in terms of kilometers per hour speed, the time 30 minutes have to be converted to 0.5 hour. And then when you do that, you will end up with 12 kilometers per hour. The stationary or the chatty part is for 30 minutes, and the speed is always 0 during that time. Then she walked back at the same pace. So she covered 6 kilometers and same pace, so her speed should have been 12 kilometers per hour. Then she rested at home, so the speed is again 0. And then this time she cycled with twice the speed. That's what it says. So 2 times 12 is 24. So her cycling speed is 24 kilometers per hour. So there you go, guys. That's the analysis of her speed. And this is the graph. Your graph should look something like this. I hope you have become now experts in distance time graphing. All right, guys. Thanks again. Thanks for watching and learning. Have a wonderful time and wonderful day. Bye-bye.